Hey everyone, this is Jonas with AccuRC, and we thought we'd bring you a new little video series as there's probably no better time than right now to improve your flying on the sim, to do some practicing, to improve your current skills, or to just learn something new. So sit back, relax, follow along, and let's get started with corkscrews. So the first thing we're going to look at is what a corkscrew actually is and how it's flown. So I'm here with the Synergy 696 on our beautiful Urcha center stage scenery, and let's do a corkscrew. The basic idea is to have the model rotate in place in a kind of knife edge orientation while alternating the collective so that it does this kind of tumbling motion. Essentially what we're doing is a sideways funnel. And if you think about it, the motions are very similar. If you look at my sticks, my roll and my yaw are basically in a fixed position, and I'm just alternating collective to control the position of the model. And that is very reminiscent of a funnel where you actually also are holding, or rather controlling, aileron and yaw to give this compound motion between yawing and rolling. So you see, if I take out the yaw right now, the model starts rolling, and if I took out the roll, it would start yawing. And if we do this in this situation, we can create this compound motion, which is pretty much a funnel in place. And what we are doing now is we are taking this motion, turning it 90 degrees on its side, and making a corkscrew out of it. So let's take a look how to get into it. The basic idea is that you can split up this maneuver into different sections. So what I like to do to initiate the corkscrew is to pull the model back beyond vertical and then use opposing roll and rudder inputs to get the motion starting. You can also do it with roll and yaw in the same direction, but that's a bit of an odd one, and I have not really practiced that, so I'm showing you my method. So one neat thing about AccuRC is that you can slow down the sim speed to 30% or something along those lines. We're not gonna quite go to 30, we'll start with 50. That's a neat way to slow down the simulator and to get some basic ideas of how to do the maneuvers we're trying to teach. So the first step to learning the corkscrew is pull back, give alternating roll and yaw, and stop. Give alternating roll and yaw, and stop. Give alternating roll and yaw, stop. And by doing this, you can give yourself some time to think in the end stops on how to correct the maneuver. Am I coming out cleanly? Did I give it too much yaw, too much roll? For example, if I'm giving it too much yaw, I may come out too steep. And that is bad because I cannot get sufficient lift in the other orientation to counteract gravity. And the next step would be to do one full revolution. So you get into the starting position, hold these sticks opposing, and get back. Hold these sticks opposing and get back. You can see that while you're doing this, the rotor has a phase where the heli is actually more upright than inverted, and in that phase you need to give it positive collective. So negative, positive, negative. And then if you're confident with this control method, you can start doing full corkscrews. So you give it, I usually just do full aileron because my rotation rates are set towards comfortable. This is the default 3D setup in AccuRC, which I'm flying right here, so no modifications on that part. So now that you're confident with your corkscrews in slow motion, we can actually go in and turn the sim speed back up to 100% and get a feel for how it controls if we are doing it a bit faster. So now everything is twice as fast again. As you saw right there, gravity accelerates the model twice as fast, stick inputs need to be twice as fast, the rotation rates are twice as fast, and yeah, this is the right time to just practice the collective timing, to find the right position for your aileron and rudder, and do some practicing before we get to how to control the corkscrew with elevator and collective. So You can use your elevator to manipulate the orientation of the corkscrew. So for example, if I want to rotate the corkscrew around in place, I can give elevator whenever the nose is in a horizontal position. So maul is facing to the right, I give it front elevator. Maul is facing to the left, I give it back elevator, and that way I can rotate around. That was not held in place very nicely, but you get the idea. There we go. You can also use the collective to manipulate your position in space. So if you give it more collective, the maul will start climbing. If you give it less, the maul will start falling. You can also use collective timing to move the maul left and right. So if I delay my timing a bit, the maul will move to the left with right rudder, it would move to the right with the left rudder. And if I advance my timing ahead of the rotation, I can move actually to the right in right rudder and to the left in left rudder. And the idea behind it is that usually you are at peak collective when the nose is either up or down. And by delaying or advancing the collective timing a bit, you can actually change the lift vector to push you sideways, left or right. And if we combine all that, we can, for example, do a corkscrew loop where we manipulate the collective to bring the maul around in a looping motion while corkscrewing. The last thing I wanted to do is to look at the difference between a corkscrew and a Piro TicToc. So a corkscrew, as we've learned, is this sideways funneling motion where the rotor kind of tumbles, whereas a Piro TicToc is actually a TicToc where you stir the stick to have the maul execute an actual TicTocking motion, whereas the corkscrew, once again, is just tumbling. The TicToc is actually a clean TicTocking motion, just like your normal TicToc, where the rotor moves back and forth. The Piro TicToc also aims to do this with the rotor where no sideways components are involved. So yeah, I hope you found this little video helpful. Let us know how you liked it. We may do more in the future. Thanks for watching.